Welcome everyone to today's Space Syntax Lab seminar. The focus of this session is space depth analysis via agent-oriented programming, a review and update of space syntax methodology. It will explore the integration of space syntax with agent-based system features within the NetLogo environment, revisiting foundational experiments and advancing simulations to provide richer insights into spatial dynamics. And for those of you unfamiliar with NetLogo, this is a multi-agent programmable modeling platform widely used for simulating complex systems. And we are privileged to have with us Dr. Anna Cocho-Bermejo, an architect and researcher based in London. Anna's work lies at the intersection of artificial intelligence and design for the built environment. She holds a PhD in technology and architecture and an MPhil in artificial intelligence. And she is an alumna of the Architectural Association's Design Research Laboratory and the Bartlett's Adaptive Architecture and Commutation Program. With extensive expertise in distributed artificial intelligence and machine learning processes, Anna is at the forefront of research exploring AI-based innovation in architectural design. So please join me in welcoming Anna to present this fascinating research. And just before we start, if you have any question during the talk, please post them in the chat so we can address them all during our Q&A at the very end. And with this, I'd like to hand over to you, Anna.
Oh, thank you so much. Thank you so much, Kimon. First of all, I would like to thank you for giving me the opportunity to share my research here, because for me, it means a lot, as it was here where the first conversations happened, and the whole initial debate about the research I'm introducing today started, because I was lucky enough to be part of the last cohort Alasdair Turner taught when I was a student at the Bartlett. And the research I'm showing and here today started on some of those conversations about that time where the whole implementation of the agent-based analysis was taking place and was being debated and improved by Alasdair for the map. So the research I'm presenting here today was developed at the Barcelona School of Informatics with Dr. De Jong, that is from the Artificial Intelligence Research Center from the Spanish National Research Council. And as I was saying, it's a type of focus that has been in my mind for quite a few years. At the very beginning of these conversations, I was already embedded in my first PhD, and I was working with neural networks. So I've been since then following not only Alasdair's work, but also every conversation and every debate that was happening since then around agent-based analysis for the DepthMap software. So when I had to decide the topic of this second MPhil, I keep on investigating, and I realized there was still quite a gap in knowledge regarding the agent-based system implementation, being a proper agent-based framework, the one being at the background of the agent-based analysis that was implemented already in DepthMap. So just for a little bit of background, mainly the 3-4 implementations that are, let's say, more advanced in the topic are quite recent. So I'm mentioning here Petros one in 1990s with Tassos Varoudis, also Isaki et al., and one that I will be explaining a little bit further because I took some inspiration for some of the processes they follow, was the one of my talk from last year. So also being perfectly aware that there are already some visual tools that are available for everybody for developing agent-based analysis with space syntax protocols. It came to me the idea of truly trying to finally develop a framework within a proper agent-based a software or platform that was going, in my opinion, and following from the very beginning the whole idea of DepthMap of being open source, just a validated framework for being able, other researchers, to build on the initial framework I am presenting here today, and going ahead with proper agent-based implementations following the initial steps that Alasdair presented in his latest work. So the main question that was in my mind since then, it was basically an inner criticism, a personal criticism, because agent-based analysis is devoted especially to agents' communication and interaction, and that was at that stage something that was not really happening, apart from other elements that are proper and fundamental for agent-based analysis. That was not currently happening in DepthMap. So from that question, if that was the agent analysis implemented was a proper agent-based system or framework, the whole review of the methodology, the types of analysis that were available so far. Obviously, I was working for this research with DepthMap 10, that was by that time the latest version and the most advanced, and the whole 5 main, let's say, analysis were taken into account. But obviously, as I mentioned, it was mainly going to focus this research on agent analysis. But another type of analysis that Turner used for the mathematical demonstrations that will be really relevant also for this research would be the through vision analysis. So keeping that in mind, the review of the implementations and all the conversations from the very beginning about agent-based navigation and how the initial conversations on natural vision and Gibson's ecological theory were studied, and all together with these main 2 approaches that I must mention, keeping through vision in mind, but focusing on the implementation on a platform fundamentally for the agent analysis part of the process. Then a more in-depth review began on the protocols implemented, the flow charts, the different variations of the decision-making processes of the agents existing on the platform as per se. So upon that previous review of existing approaches as some initial tests like the Tassos or Petros ones some years ago, and all the initial debates about how to implement these agents' decision-making processes, several variables that were needed were kept, and others were discarded for the purpose of the development of the platform. Some of them, in this case, will be relevant for the agent-based navigation, and other ones will not be implemented at this stage for the framework. So The research objectives were established there in the sense that they were going to be divided first on trying to find a method of validation for an initial development of the framework on a agent-based platform. I will explain in a while why NetLogo was chosen. Then it was decided, the case study to implement that, as you can guess, for the image that is on the screen already, was the well-known example from the very beginning of the Tate Britain. And then two phases were considered: the one after validation of the platform, the one of implementing a similar test to the one at the Tate Britain with no attractors in the system, and a second test implementing two relevant agent-based systems characteristics, and those two were attractors. We will see that they were implemented in the forms of paintings or sculptures in the museum, and the second one was communication in between the agents. So as I was mentioned, from the existing approaches that the main three that I mentioned before, there was one that was quite relevant for me, and that's the one of Ma et al. It's a quite recent one. It's just a last year publication, but that one was really relevant because despite their approach was on an urban scale, it was greatly inspiring the way in which they decided to go for the process of mapping the grid that was creating for the environment. So in that sense, Ma et al., let's say they label the different patches of their environment regarding their walkability characteristics. And that's the characteristic that the agents that obviously following the initial principles of DepthMap agent-based implementation are not having a map of the environment. So the only information that they will be receiving will be the walkability of the patches around them, and that all together with the implementation of the visual movement, the movement through vision, mimicking Alasdair's initial approaches, was the main inspiration that was taken from Ma et al. We can see here on the left some of their experiments trying to understand how the influence of different angles of vision for the agents and different distance of vision for the agents, the different results that were given. And on the right, we have this diagram they are presenting precisely on the way in which they map and they give this characteristic of a walkability or of 0, 1, or an intermediate one, depending on the type of patch on the grid that the agent is surrounded by. So as an example, obviously a wall will not be walkable. A pavement that is a little bit different might have a walkability of 0.7, or a pedestrian sidewalk will have a walkability of 1. Okay, because we have to remember that they were working in urban environments. So taking from that this approach of labeling the different patches of the environment as a way in which we will be able in our framework to map the 2D plans and 2D information that we are going to import in the framework from different building plans, and building on their conclusions about the relevance on the angle of vision over the distance of vision, the methodology was proposed. So the very first part of the study was quite simple. It was basically trying to mimic Turner's observations on the Tate Britain with the current existing version of DepthMap, and for trying to validate that the results were still able to be reached with the current platform. Second phase was the development on the graphical interface and the agent-based system and framework, and the development of a method of validation for being able to test that the framework was working adequately and was giving the expected results on such a well-known case study. But at this phase, not yet with communication implemented in between the agents, and not yet with attractor implemented within the environment. That will be the basis of the last phase of the methodology, of the phase 3 of the methodology. So the whole idea was to understand from the very beginning how to establish a validation method for the framework that was about to be created, that was able to to state that the framework was following the principles and was given the same results on a well-known case study for them being able to aggregate proper agent-based system features. So some studies were developed about what type of plan of the Tate Britain should be implemented, because they are very well known studies of the refurbishing works that were developed at the Tate, also with space syntax. So there was a little bit of a process trying to understand how to map and how to plan for the correct approach. At the very beginning, it was consider the initial validation method that was developed by Turner with the observations of real human beings from the early 90s approaches. But the problem with this type of validation was that we were not having the real observations of the real people that were used for the initial validation test. So this type of validation that was developed of the correlation between the automatas and real people passing through the rooms of the Tate Britain was one that we were not able to pursue because we were not having the data. So then we jump into Alasdair work on the mathematical demonstration on through vision. That was for us a very interesting approach, because then if we were able to develop with our framework a similar through vision diagram and a similar diagram of our agents with 170 degrees of field of vision, with a similar mathematical correlation result, then it was for us a good sign that our platform was getting minimum the same correlation that was obtained by Turner when he developed this mathematical demonstration. So that was in the end the validation method chosen. So in that sense, and going back to the methodology, we jump into the very first phase of the research, that was to mimic the analysis of the Tate Britain with the current version of the map, developing the integration diagram for afterwards jumping into the proper development of the platform, running the validation experiment that was established, and then for the third phase, to come along and implement communication and attractors in the system. So on the very first phase, as I said, we developed with the current version just a very simple mimic exercise of the agent-based analysis of the plan. We can see here that the plan is incorporating already the refurbishment on the northeast areas of the museum. So the diagrams were developed just to be able to test with initial published Turner's results, that with the platform we were obtaining still the same kind of diagrams for the navigation of the space. So on the left we have Turner's one, on the right we can see the type of diagrams we were obtaining with DepthMap 10. And after that initial exercise, we started all our considerations on the development of the framework, of the agent-based framework. So the first step at that stage was to consider what type of agent framework we should be using. So this is a diagram just showing some of the frameworks that were considered. The whole point of the experiment, remember, was to try to validate the results for afterwards implementing and setting the basis of further implementation for other researches or other agent-based features. Some of them were discarded. This diagram is showing the relationship between the modeling power and the ease of development. And as you can see, the one that it was chosen, that is open source NetLogo, it was one of the initial ones, one of the earliest ones. It's quite a powerful agent-based framework and is quite friendly. And also it was really important for us that in the recent years, it was also allowed communication with GIS. So in that sense, for us, it was a clear sign that if that platform that we were creating was working and that was possibly being able to be directly connected with GIS via NetLogo, will be a clear advantage for them being able to jump from buildings to urban environments. So in that sense, NetLogo was chosen. NetLogo uses the Logo language. And two main goals for the framework, once validated, were implemented. The first one, and the one that was kind of more relevant to us, was the implementation of some sort of agent communication when navigating the space of the museum. The second one was the implementation of two levels of goals: micro goals related to the decision-making process for the movement, and macro goals regarding the main goals implemented as quasi-human beings visiting those spaces. So also NetLogo was considered because it's as a very user-friendly platform that is in fact used in several fields, not only merely in computer science. And so the next decision making was regarding agent architectures, because agent architectures were going to be the basis of the implementation of our agents reasoning. There was a lot of debate going on having some type of learning on our agents or not. There was a lot of debate about keeping our agents with the sort type of memory or not. But at the very end, we decided to start step by step from the very beginning, from the early implementation, from the early existing implementations, to be able, if validated the framework, to go ahead with the next scaffolding approach, adding more complex behaviors for the agent. So in that sense, in the end, a reactive architecture was the one that was implementing for the study. The framework allows other architectures to be implemented if needed. The sample that was validated was the one with a reactive architecture that was chosen due to the simplicity of the agents, their adaptability, obviously the low computational cost, and also because at the very beginning we considered that those was the type of architecture that was more similar or closer to the initial experiments developed by Turner. So last step of our decision-making process was also a whole debate on how to implement our pedestrian dynamics, because again there was a whole debate about following a classical approach, a simulation-based approach. There was a whole debate about micro and mesoscopic models. And again, several different approaches were considered. Macro models in general were discarded. Some micro models were taken into account. And after several conversations, one that was pretty interesting to us was the one implemented by Song in 2022, completely different approach. It was for earthquake simulations, but their ideas of considering, for example, doors as static attractors, and was really interesting for us. And in the end, we implemented a very, very simple pedestrian movement that was mimicking absolutely initial Turner approach. In that sense, we try to create the framework as open as possible after validation, so all knowledge can be built on it. So it's quite easy to modify agents' behavior and go a couple of steps farther, adding some short-term memory for the agents or some type of evolutionary learning. But those were no behaviors included in the of the platform. So also simulation softwares for evacuation of buildings were studied. Also Unity agents were considered. There were some experiments from Barodis and Petros thinking about how to use the Unity, but the control we needed about being quite rigorous on how to implement our agents' behaviors to be sure we were creating a framework that was going to be able to be validated as following the same process as DepthMap. Let us go in the end for a very simple approach on the mimicking. So this is the final flow chart of the decision-making process implemented. Is a variation of the two well-known ones for the map. The main variations here are regarding, as we can see, the general goal implementation and the implementation of the message passing. And the one on the top right is the one regarding and analyzing the goal of reaching the general goal or not to be established. And the one that is in the middle of the screen on the left is the part of the flow chart that is analyzing if my agent is receiving any message. That, as we will be seeing in a moment, it was considered on this experiment after validation to be a recommendation for visiting a paint when crossing paths with other agents. So in general, the main goal, the general goal established was to visit the maximum number of paintings in a reasonable amount of time. Paintings were weighted depending on their importance in a random way. In this case, 20% of the agents we will see will consider to have a measure whether it was a recommendation of a painting or whether it was a recommendation that the museum was closing, that there was the need of leaving. But as I said, those were behaviors that were implemented in the phase 3 of the research once the validation took place. So for this validation, as we said, we went through the third vision mathematical demonstration published by Turner. So the very first thing we did was to understand how to implement in our framework created in NetLogo an automatic calculation of the through-vision diagram once that a plan was read by the system. So simple calculations, straightforward from his findings, were implemented. The Berisham algorithm was also implemented when some visual lines from the agents were tackling different patches of the grid. And in the end, we can see here, we are showing some results here. The integration diagram on the left is the one that we obtained with DepthMap 10, and the integration diagram on the right is the integration diagram that was obtained with that NetLogo platform once that this through vision calculation was implemented. So having finished this first phase of creating, being able to develop the two through vision diagrams with the two platforms, we jump into the creation of the graphical user interface and the proper framework in NetLogo, and the validation methodology for the calculations with 19 agents mimicking the behavior. Some main differences between the agents' behaviors in DepthMap, as I mentioned before already, some of them, and the NetLogo proposed model are that, on the contrary to DepthMap, in our model, agents are aware of the existence of attractors. In this case, shown today, they are attractors in the form of paints with different weights. Agents communicate between them with message passing. Blackboard message passing was discarded because we were willing to keep very, very rigorous the idea of the agents not having a map of the environment a priori. Avals, in our case, were able to see other agents, so no rule for avoiding collision was introduced because they were aware of themselves and others. And also the possibility of agents coexisting on the same location was implemented. On the other hand, several things are implemented in the same way. So the movement rules are basically based solely on the building configuration, based on the previous mentioned walkability mapping of the patches, and on the visibility degree of the agents, the distant vision of the agents. They are also moving with a constant speed. And they have an access of a lookup table about the environment, but it's mostly regarding the attractor weights. At this stage, no socioeconomics are considered. There were some debates whether or not we should implement some flocking behaviors, like, for example, the behavior of a family visiting the museum all together. It is supposed that, for example, kids should follow the parents, but it was not done at the very beginning. So particle swarm-based behaviors were discarded. So this is the final interface that was designed. We can see here that we have already a simplified model of the Tate Britain. These little red dots that we see on the screen are paintings, considered attractors with several weights. We can see that we have some sliders on the left that are allowing us to choose the number of paintings in the form of attractors, the number of visitors. We can choose also, if we want, we can change the vision angle of our agents. We can change also the vision distance of our agents. We can establish a different time to remain of on a paint when an agent has reached a paint or a different attractor. And what is calculated there that we can also see is a value that is called alpha. That is basically the through vision diagram value that has been calculated for every patch. So at every round, the maximum through the maximum alpha, the maximum through value that is reached at that particular plan of that particular building is mapped on the graphical user interface. So as I was saying, after all those considerations, we jump into the validation protocol. So at the very beginning, for the validation, no paintings were included. Third phase will include 19 agents and, if I don't remember it wrong, 70 paintings. So the framework for the validation was run in several rounds. There were several tests at the very beginning, just testing the angle of the angle of vision of the agents for being sure that we were mapping correctly the agents 15.3 on Alasdair work, and then the 19 agents were implemented. So the results for those validation after running the test, we can see here some of the runs. Run number 12 here is showing some results after with no attractors at this stage for validating the framework. Just some samples here showing, if I don't remember it wrong, these are 400,000 steps and 1 million steps that we can see on the screen. In blue, we see the paths of the agents navigating the spaces. So not attractors in the system yet, so merely navigating, mimicking the depth space navigation at this stage. So we can see that the agents for the agents, it takes a while to abandon one room and go to the next one, but that was kind of a behavior expected. So the previous diagrams were showing paths. This diagram is a little bit different one. It's showing the number of times an agent is visiting a patch. So after those first tests, the numbers were developed for the validation of the framework. So 3 main calculations were taken into account. The mean square error was the first one. Pearson correlation, obviously, to be able to compare with Alasdair's results, and then a pixel to spatial deviation calculation, being able to overlap both diagrams, ours and Alasdair's on a grayscale. So this is the result that we obtained for the platform at this stage. So what we see is that the Pearson correlation, it was pretty similar to the one that he obtained when comparing his agents with the through vision diagram results. So that was kind of very interesting for us. And then the scatter plot of the pixel to pixel deviation showing the centroid of the deviation. And then jump into our very last phase. That was the phase in which we were implemented one of these results, validated our approach. The new propel agent-based features that were the message passing, meaning communication, and the attractors in the forms of paintings. Here on the screen, we can see the type of runs that were developed. Again, at the very beginning, just one agent trying to understand the behavior. Afterwards, 19 agents, as in the original human tracking. And the very beginning, 75 attractors, in the end, 200. So tests started trying to map the paths of the agents, trying to reach the different red squares on the screens that were on the screen. There were the different paintings. The weights of the paintings at this stage were random, but obviously that opens a wide range of possibilities regarding the idea of understanding how visitors will behave with different locations of different paintings with different relevance once the museography is being studied for a specific exhibition. And then the agents were having not only the interaction with other agents that were recommending what paints to visit, but also we're keeping a track of all the paints already visited, trying to understand if they were visiting the adequate ones, or if they were being or they were being in a good position to reach their goal of visiting the maximum number of paints and rooms in a reasonable amount of time. So as we can see on the screen, agents were having at the back end a process of decision making that was keeping in mind if a paint was already chosen to be visited as the next one or not, or if they were waiting for a recommendation of a painting, or if they were just following movement by vision in the same way it was happening in agent based in DepthMap. And here we can see a little bit bigger how the agents were keeping track on how many paints that were being visited already, and checking if they were visiting the same paint twice or not, or if keeping also the percentage of paints visit track at the back end, and also checking if there was any recommendation. That we can see on the screen that when there was no recommendation, what was said to be moving randomly is mimicking the behavior we mentioned before from DepthMap. So several runs. Again, most of the agents check a good number of paints in the time it was given. The time that was chosen to be a reasonable time came from several prior studies on museums. According to several authors, it was established that a reasonable amount of time for visiting the Tate can be approximately 2.5 hours, and depending on that, agents were left for 1 million of steps. That was also in some of the papers published mentions as a reasonable number of steps to be taken into account. So we can see that despite some agents get stuck sometimes in some rooms where rooms are not located in the existing room next to them, in general, behavior, obviously, as expected, was quite different. And we can see from the diagrams that one of the behaviors that we can take into account, and it was quite surprising for us how still when we were developing our research, the proposal, how recent an advance it was at that time, was Alasdair's latest proposals and the latest publications about the animats, because and I am just trying, just while I am speaking, just to show some more of the behavior of the agents, different timings and different runs with these goals implemented, were quite, as he mentioned, rectilinear in some sense, and was a little bit changing the approach as supposed by the author when all these attractors and different approaches were implemented. So this is a closer view where we can see the different paths in the different behaviors in the agents. It wasn't a surprise, but in any case, it was a good validation for setting this initial framework to work on. And this, I was mentioned, was one of our initial approaches to be implemented that we discarded and included as a matter of further research, and we haven't done so far. That was this implementation of some sort of AI learning based on this latest animats proposal. But this diagram for us, with the rectilinear paths that he developed, when we compare it to our finals, was really revealing, in the sense that was showing real advancement in thought already 15 years ago. So main findings, just for finishing. So for us, most important finding for us was that we were able to validate through the correlation obtained, that our platform was obtaining a similar one to the one obtained at the very beginning by Turner, and also that the behavior of the agents, once established, the attractors and the method passing, was starting to be close to one of the guesses the author was proposing regarding the automatas ANN implementation. So for us, that was kind of a good ending, if I might say, because it opened the door for us to, from now on, start adding more specific agent-based features, and start varying the behavior of our agents, once that we have tested the initial implemented behavior and prove it as a valid one. So the whole idea of the platform is, and with this I finish, is to be an open platform, completely open, so that everybody can work with. At this stage, obviously, the 2D mapping from the plans and the building plans that are read by the platform is quite simple. So it works in a similar way. We have to implement our plans in DepthMap, implements a similar grid based on the human size of human step. But we believe I believe is a very good start for building some more knowledge on it. So we'll be happy to go ahead for some questions. I hope it was a little bit, at least a little bit, interesting for the public. I'm a little bit excited, as you can imagine, to show this research here today at my former home. So here is my email, my contact, in case you want to have some interesting conversation about it. So thank you very much.